All right, we are going to take the my class OOP example and create some loaded dice. I'm going to go through and rename things. I think main is a perfectly good name for the main program, but I think my class is not very helpful. I'm going to call it a die because a die is a single dice, and that's what we're making. We're making a single dice, which means we need to change these guys. So I'm going to rename them to, right? Because this is the implementation file. This is like the header, what is it called? Header prototypes. C++ works differently in that it is, I should be consistent with my names. And that it has to tell the compiler what to do and where things are and all that. C++ is very low level, very fast, used for writing drivers and things, games, all that sort of stuff that has to run very quickly. But we have to put things in here to help the compiler figure out how to put the program together. And this is one of the things that we do is we put together a header file. So it's like a header prototype. It tells the compiler, oh, by the way, Mr. Compiler, there's going to be all these variables and classes and things coming up. And then it knows that, okay, and then it finds this and says, oh, I see, these are all the things that we're actually going to put in there. So we're getting a little deeper with C++ as to what Python and everybody else does under the hood. So yes, we want die.h. Yeah, e.h. Yep, there we go. Oh, and I got my friend, Mr. Turn off this guy. All right. I do not need any help. I'm fine on my own. So it says design a die class with a data field for an integer value. The class die rolls and returns one random integer dice value. That's it. There is no other functionality. We have a question from Owen here. He looks like he didn't. All right. So we're designing our die. Am I in my die class? Yep. So this is the die class. This is the implementation, meaning this is where things get done. And here is where our function headers are. So we have to say, yes, Mr. Compiler. Oh, I should make that a better name. F2, well, let's just go die. And it replaces die everywhere, except for some reason, C++ like has to look through everything and figure out what it's doing. So far, I've just, made changes and it's good. We'll see if it messes things up. Oh, it did, because that's supposed to be, according to our conventions, almost always, well, at least in the languages we're using, a class is defined with an uppercase. And we must have something else going on here. Yep. So these have to match because this is implementing. Yeah, so I renamed too many things, didn't I? So we typically use uppercase to indicate that it's a class definition and lowercase to indicate that it's an object. So that's one of those conventions that allows for, like me, for example, to read through your code very quickly. And the other convention is nice spacing, everything lined up. I can scan through this code and figure out what's going on way more quickly than if things are jumbled all over the place and there's no indentation and stuff. So in Visual Studio Code, it has a built-in formatter, which on Windows is Alt-Shift-F. I don't know what it is on the Mac. You can't right-click on the Mac, and I don't remember where it is. It's somewhere. Up here, I just haven't used it for so long, I've lost it, but if you Google it, you'd find it. Because auto formatting a file is part of most integrated development environments. Because they realize that, yes, you rarely start out your own code and live with it for the rest of your career. They're always digging into somebody else's to try to figure out what in the world they did. And then you're going to be cussing them saying, well, why didn't he document whatever the heck this is? So we have to declare the prototype of the variable. You know that's going to be an int. Private variable is probably not a good name. We're going to be returning a dice value, right? So maybe dice value. I don't know. Sounds good to me. Now make sure this guy is good. So I'm going to change this so that I can have these guys side by side. There, then I can make changes better. So the M means, what does M mean? Why do we put an M on there? I could put it at roll, couldn't I? No, dice value is a good name. What do we have? Why do we have the M? Anybody remember?
It's my, I think.
Yeah, that's kind of what it is. It means member variable is what it is in C++. So that means it's a member of, but that's only a naming convention. There is the, oh, I can't remember what, it's not this, but there's another way you can do a little wiggly thing in front of it that says this, but this is implied. So I use this instead. I mean, I use M instead to indicate that it's an internal variable, where this is something coming in from outside the world. Then you can easily see what belongs to the class and what does not belong to the class. And we're probably going to do this differently. We're going to change that to get die value, since that's kind of how I started out doing things. DIE, VALUE. So far we haven't done much except realize that I kind of gave you half the assignment right here, didn't I? Just a matter of plugging in the right stuff, right? Ah, I can't type a V today. There we go. And this is giving us trouble because our prototypes are not right. So we need to have our prototypes match what's in our implementation file. So we have set die value and we have get die value. And the only reason we're returning, I put a string representation in here. And in our case, we don't need a string representation because all that's being returned is a single integer. So we can just do without that. I mean, you could do it to a mistake and you could put it in there, but I think we'll just leave it out. It's not really needed. I don't say you have to have one, do I? No, I don't. Because we'll do all our display in the other program. All right, so it still doesn't like me. Oh, I have dice value. It should be die value, shouldn't it? Let's get our cases right. And yeah, see, I have a mixture of things. Never good. Die value, die value. So far, we're just changing the names to protect the innocent, which is a reference to an old TV show. Dragnet. These are real stories in LA. The names have been changed to protect the innocent and all that. This should also be changed because it's not my class anymore. This is a header guard, so you can't import it more than once. So we would call this die. Does it have to be called die? No. These just have to match. So you can't import this more than one time. That's all that's for. There, I think I have everything now. We're going to die. Oh, yeah, whenever I look at this long enough, I always think, oh no, this program's going to die. That one's lovely, and that one's lovely. So is there anything else we need? Well, yeah, we have to actually roll the dice, don't we? Because we can get the dice, we can set the dice, but really, do we want to be able to set the dice? Aren't dice random? Yeah, so our set die value really doesn't make sense. That's going to be our roll die method because dice are random. So we're going to roll the die. We're going to roll the dice. So that is going to be our setter, is to roll the die. And then that's going to be the same. Because we do need to get the die value, or do we? What does the direction say? Ooh, it says the roll die method generates a random integer and assigns it to a member variable. So I think we'll leave get just in case we need it. You don't have to, but it does say the roll die method returns the value generated. Right? So we don't really need this, but we'll go ahead and keep it anyway. So that means we're going to return, which you can just stick that in now, our die value. That's what's coming out of this. But we don't need this, do we? Because we're not passing anything into it. We're generating a random number inside this and then returning an integer. Yes, Mr. Andy?
Shouldn't it be an
In a, not normal, but in most, I guess, object-oriented programs, when you are getting something, you're returning of, no, this is set. Yeah, when you're setting something, you are bringing in a value. Well, in this case, we're generating the value inside. So we don't need to set anything because this is setting it for us. And as Andy mentioned, yes, it's not supposed to be a void because we're returning an int, which is the data type of die value, which we declared over here. I know having two things in two places is confusing, but so that means that at this point, our prototype does not match. So we take that out and we declare it properly there. So it's as if we're declaring the value of roll die is an integer, which it is. We're returning a value. So in effect, this method, any method that returns something, in effect, this is the value. Calling the method brings the value right back to that method. So in effect, it's a value. Well, randomization, of course, in C++ is just like anything else. It's just you have to include 50,000 things. So in the assignment, we want to include the standard library of C, or maybe that's C++, I don't remember. Anyway, this one gives us our randomization functions. This gives us our time. Well, what's time for? If you use a randomization function in C++, you'll get the same answer every time, which is not very random, is it? So what we do, and I think we've done that with other stuff, we seed it, meaning we initialize the random number generator with a value that's different each time. So that gives us a different sequence, and that's what the time is going to give us. So what we want to find, and this has to do with Unix things, it's time since January 1st, and I have set 1070. There weren't computers back in the Middle Ages. That's supposed to be 1970. The first Linux, they officially, this is called Unix time. This is when the first Unix system, theoretically, I think it was up and running. And so Unix systems count everything from this value up. And so it's called Unix time. And many programming languages use the same thing, or they can deal with it. In C++, time zero means time since that date. And why is that? Well, because C was used to write Unix. And it still is. C is still used to write it. Oh, C, C++. They didn't have C++. Well, maybe they did in the 70s. But the only difference between C and C++ is objects. That's the major one. All right, enough of that. So we do need to, where does that go? Goes in the constructor. There it is. There's our constructor. All right, so we need to, every time we construct the object, we're going to randomly, we are feeding the time so that it's different each time. That's what SRAND is for. I've always thought of it as like seed randomization. And that's what they call it when you set a random value for the start of the random number generator. And this will change every millisecond. So we've had 25 hundreds of them already go by. So right at this exact millisecond, it generates the time and it uses that to actually roll our dice. Well, and then the next thing I say is this goes into the roll die method. So that took care of that. We need to return our value. And there it is. Random number. Well, C++ doesn't have a random integer. So it generates between 0 and 1, so it's point blah, blah, blah. Well, what we want is is that right? The remainder if you divide it by 6. No, I think it just generates random real numbers. And then we use 6, and then we end up with 0 through 5, but we really want 1 through 6, so that's why we add the 1. And this really should be roll. There. Is that a thing of beauty or what? Oh, what did I miss? Why is it red? What do you think, Andy? You should be able to catch it. What about you and Sonia? What am I missing here?
You haven't defined what kind of variable it is?
Yep, you always have to put in the data type. And I don't have to initialize it unless I know the value. I initialized it here because it's part of the constructor. So you could initialize that to any variable, but you do have to initialize this. And when you're constructing the object, because it's part of the object. This one is only inside this method, so I only need to initialize it here. And then we get our random value. And then we can also get our random value, but we'll use this one since it does everything all at once. So there's no wiggly things. Everybody looks happy, right? What do you think? Have we taken care of all of our stuff that's in here? Yeah. All right. So now we're going to test it. We're going to create 2 die objects. That would be our main. And we're including our die.h. There we go. What am I missing here? It's giving me red wiggly things. That's never good. Sometimes it means something, sometimes it doesn't. I've got it backwards. You put the class first and then the object, which is the reverse of every other of Python and Java. Python and Java, you go the other way around. So die becomes our object. We use die dot roll dice. We aren't not passing anything in, correct? So this brings back our integer of when we roll the dice. I should probably call this die 1, shouldn't I? Because it says to create 2 of them. So it'd be better if I had die 1 and die 2, you know, like thing 1 and thing 2. Or you could call it thing 1 and thing 2 if you want. So we're going to roll this guy. Now it could store it in a variable, couldn't I? And use that.
Yeah.
But I can also just use this as a value. Just like it is, because it is returning a value, and that means that this actually is the value. It's like that's your variable at this point. When you first hit it, that's a method call from the object. When it comes back, it's the value. So we'll use it that way, just for a change of pace. And then we roll die 2. We have 2 different things. And now we do our cout. You know, we can put in all kinds of stuff, but I'm just going to put in the die. And we're not doing toString. We're just displaying these die 1. Uh-oh. If we're going to do it this way, we stick it in the middle of the thing. So I think I'll stick with my, let's, you know, create a let's create a variable. Uh-oh, can I do that? Can I have an object and a variable at the same thing? Let's find out. What do you think? Is it going to compile? That should, because this is the object. This is a variable we're declaring here, so it should work. I hope it works. We'll find
Come
out.
back with an error, so.
Oh, when you compile it like that, it gives you an error?
No, I mean, it's not coming back with any errors yet, so.
That doesn't always mean,
Yeah, it doesn't mean, it just might mean it just didn't catch it.
yeah, it might, the compiler may catch it. I think it should work because this is coming from somewhere else and this is internal. We're declaring it here. I don't know. We'll find out. We could always do this and then we would be safe, right? Die roll 1, die roll 2. Now it's not gonna blow up. So now we need to display our die roll. And we'll just put in a little thing that says roll 1. And yeah, we need those. So when you are displaying variables, it's a good idea just to make sure nothing blows up, because I've never done it any other way, to have a string in there. And then it does what's called implicit casting. It implicitly casts this because you cannot display an integer on your console. It does not work. It has to be converted to a string. Well, this implicitly converts it to a string. At least it does in Java and other environments. But then you're always going to want to have a little something. Now we can do the same thing again. I am a fan of copying and pasting, not of somebody else's code, but of your own. And then we have 2. So now we'll get our die rolls. What do you think? And Sonia, is that kind of close to what you had? No? I think that's all it asked for in this one. Maybe a while loop, but I don't remember seeing that.
Actually, didn't it ask for you to like do about 1,000 rolls and say?
Oh, yeah. But when I'm developing a program, I start off.
Oh, that's fine,
Yeah, and I would recommend you do the same thing. Because if you try to do everything at once, well, then you have to troubleshoot more. At this point, we should get 2 random die. And that's all I want to do at this point. And compiling on the Mac, yeah, is a mess. But on Windows, it's much simpler. I have a little batch file to compile it. Inside, excuse me, you could do a shell script. Yours would be whatever it is .sh. Did you do that?
Yeah, you have to change a little bit, but
Your command line is going to be different. I remember we looked at that. On Windows, you do G++ -O, which I forgot what that means, but that's our executable. And then you don't have to do the H, you just have to include these because the H file is automatically connected to this. However, we did not call it my class, we called it die. And this executable file name doesn't have to match this. I like it too, because then it's easier to troubleshoot, I think, but that's just me. Cross our fingers. Okay, well, oh, so far so good. Let's see what happens when we run it. Think we're gonna get lucky, Andy? Oh yeah, there we go. Yep, different ones. Yeah, we got 4 in a row. Does that defy the laws of statistics to have 2 4s in a row?
No,
No,
let's do it like a lot of times and she kept going up the same.
then you'd have a loaded dice, wouldn't you?
Yeah,
Because every number has an equal chance each time to come up, but that's not to say you couldn't have 10 4s in a row. And if you could do that in Vegas, you'd be rich. But we're gonna load the die. All right, so yes, you're right, Ansonia, we're not quite done yet. The next step, we need to roll it 1,000 or 1,000,000 or however many times we want to do it, right? Now we also need to compare them to see who won. Well, let's roll these die 1,000 times to start with. Sound good? So we've stored it here, we've declared our variable, but we don't want to do this each time through the roll because then we'd have all kinds of overhead. We'd be recreating this variable again and again and again and again. So one of the things Ansonia said earlier is, and this is what we should do, we should just initialize one variable, period, and not have to create it again and again and again and again. Now in our loop, and what kind of a loop do you think we should have? What do you think?
probably the for loop is one specific number of iterations.
That sound good to you, Ansonia? Is that what you did? Oh, you got your variable declared? Or initialized is what this is called. Kind of. Well, you should have created 2 objects. And we're going to have 2 variables to store the results of rolling our die. This is perfectly logical according to my directions because I wrote them and I understand my directions. That doesn't mean that you do though, however. Okay, so we do our loop we have 3 parts to our loop, right? And x equals 0 is always a good one to do because that's like in every loop ever. I mean, every loop ever done in C++ or Java. What do we do next? We have 3 parts to the loop. We have the counter, we have the
maximum, which should
yep, we have the test or
just,
the Boolean. Yeah, how do we get out of this loop? So the
so
test is going to be
x greater than 1001.
oh, it doesn't matter. This is close enough. We start at 0. You know, we'll go up to 1,000 and that'll give us 1,000 actually, because we're starting at 0. So you're right, Andy. Very good. And then we have to increment, which is this guy. This is like every loop we've used for this entire class for Java and C++. They're identical in structure. Python is simpler. It uses iterables and other things to do loops, and it's just designed to be easy. Well, what should we do next? And Sonia, do you have this part? Is your laptop dying?
Okay.
Oh, okay. Well, that's not very helpful. Should I pause? Okay. Well, so now the next thing we need to do is we're going to roll these dice 1,000 times or 1,000,000 times or whatever we want to do. So we need to do what we did before. Die1 dot roll dice, right? And we're going to store that in our die roll variable. So there's die roll 1. Right?
Yeah, I read the one at the end of the.
Oh, I did. I forgot to put the 1 in there. Thank you. Good eye for detail. And then we do 2. So now we have our 2 of them. There. And that's what it does say, doesn't it? Create a loop to roll the die 1,000 times, dice 1,000 times, dice is plural. Accumulate the number of times the first die object has a higher value than the second die object. Oh my goodness. Well, if I roll it right now, I'm not going to see anything, which is fine. How do we accumulate and compare and all that kind of stuff? Excuse me?
Equals. Whatever it is, equal,
Mhm.
plus equal, and then the other one. I think. There might be some things.
I just didn't, if one is greater than the other.
Yeah, that's correct. And now, okay. If die roll, what is it supposed to be? The first die object. If die roll 1 is greater than die roll, we're not going to care about, I don't think I care about if it'll tag. Yeah, I just want it. I just want to find out if it wins. I don't care about, oops. I just care about if you win. That's all I care about, because that's what the directions say. Okay, so how do we accumulate? Well, how do we accumulate things? How do we keep score? How do we have more than, we have 50 invoices and we can have the total from it? What do we do there?
Probably have to have a variable like for count.
Where would we initialize it? That's important.
We probably have to initialize it outside the loop, definitely.
Yep. Otherwise it will, if we put it in here, it gets reset every time. And we're just counting numbers, so we'll do int, and count is perfectly good name for a variable. Because that's what we're doing, we're counting. Or you could put in count wins or, you know, something like that. So the plus equals part you were mentioning earlier, and Sonia, that's what you do here.
Oh, okay, yeah.
So you do count plus equals 1. And that each time around will add, so count equals count plus 1 equals count. That's how you read that. You could also do it count equals count plus 1, which is exactly the same thing. This is a shortcut because programmers are lazy. And they don't want to have to type any more than they have to. But that's the same thing. we're accumulating into that same variable. Now we have everything we need. Well, I didn't comment anything, but I've been commenting verbally as I went, so that counts. So do we care what they rolled? No. We just say with regular dice, regular dice. Let's see. The first die, we'll say the first die won so many times. First die won. And we put in here count. And then I'll add a thing in here from times, I guess. Oh, out of 1,000, okay. Out of, and yeah, I could have made a variable for this. I'll just hard code it as 1,000. Out of, and we need a little redirect, guys, again. And then we put in, oh, there it is, count. There. It's a thing of beauty. Yeah, more or less. I don't like it strangling out there like that, so I'm gonna do that. There. You want to put things on more than one line when you're doing standard C out, you just have to press the enter key in front of the redirection characters. Or because they're redirecting to the standard output. We don't care about this. There. We're done. Well, with that part, and we need to make a loader die, but you know. It's all the same thing. But it does take experience. It's not just something that willy-nilly you can suddenly, oh, I didn't do my loaded die, did I? And I never finished this. Oh, this is the example. Okay, yeah. I mean, this is the one we're working on. I was gonna say there's no loaded die in there. And there isn't. So if we run this again, let's see, it compiled fine. Okay, so something's not right, is it? We won 0 out of 0, so that's not correct. Huh. Well, that looks right, shouldn't it? We have count. We're incrementing count each time. If row 1 is greater than row 2, we know we're getting numbers out of there. Well, anybody find the solution? This is debugging time. What's going wrong here? We initialize count outside the loop. Every time die roll 1 is greater than die roll 2.
Yeah, one to count. Did we?
Oh, I did count twice. That's supposed to be 1,000, so that's one of them is my error. But that's not the error. It's the other one is just not adding anything up. We're not getting we're keeping a 0 for count. And it should be incrementing each time because I have count equals count plus 1.
What was you initialize 0?
Yeah, just to get started. You don't have to initialize it at anything, but if you don't initialize it with a value, it just has a garbage number in it, which is like a random memory address. I don't know what it actually is. Huh. What's the dealio here? Well, let's see if we're actually doing anything in the loop. This is called print debugging. There are other types of debuggings, but sometimes this is just a quick way to find out. Oops, in the wrong language. Are we getting anything? Are we getting to the loop? If we see nothing here, we're not getting into the loop, are we? It's not working. So let's compile that and see what happens. Oh, you have to actually compile it, don't you? Otherwise, I'm running the old program. Let's try that one more time. It compiled properly. That's a good sign. And the loop is not working for some reason because we aren't getting that print statement. So we've determined where the issue is. So I'm guessing it's syntax. I typed in something wrong. I don't see it. Let me pause for a second, and take a look at another program that has a loop. Because I found it. How often is X greater than 1,000? I compared it to another assignment. How often is X greater than 1,000? It never is. So that's why we weren't doing anything in the loop. We need to test as long as X is less than 1,000, we're good. And in this example over there, instead of creating the variable, then assigning the value to it, with this, I create and assign the value all at once because we're initializing the variable with a value. Is that a big difference? No, it's just a more modern C++ way of doing things. Well, I don't need to see 550 numbers, but sometimes print debugging is a very simple way to fix it. Or at least narrow it down. And that's what you're doing. You're trying to narrow where is the issue down. That's all troubleshooting is like that. If it's not here, then we know it's over there. And if it's over there, how do we narrow that down into where it actually is? Hurrah! And each time we'll get a different amount. That's the nature of randomization. Now, loaded die shouldn't be any problem, because how does the loaded die differ from the regular dice? How is a loaded die going to differ? Oh, where's my loaded die? What's the only difference between them?
I'm pretty certain all you have to do is turn 6 into a 5 and a 1 into a 2.
Yeah. Because you only want 5 values, and we want to start at 2. Pretty much that's it. I don't know if that's the answer, but that sounds like that's a good place to start. Because this gives us 6 whole numbers. And if we change that to 5, because we want to roll a loaded dice against a regular dice. I think that's a good place to stop, because I basically did everything. And I know my directions made sense to me, but that's because I wrote them probably.
I've got my program mostly worked out, but I have one problem that I can't identify what I'm doing wrong.
Okay.